After studying this module, you will be able to know what is the situation of capital rationing, learn about the reasons for capital rationing, identify the conditions for selecting investment proposals under capital rationing, learn and apply the techniques to select investment proposal under capital constraint situations. What do you understand by meaning of capital rationing? Capital rationing refers to a situation where the firm is limiting the cost of its investment. This limitation could be self-imposed or external. Due to this constraint, the firm is not able to invest in all the possible profitable investment opportunities and has to allocate its budget among various proposals in order to maximize shareholders' wealth. Next, the reasons for capital rationing. Internal capital rationing occurs due to management's self-imposed restrictions. External capital rationing occurs due to imperfection in capital market. Let us understand the capital budgeting decisions under capital rationing. Next is the conditions for selection. When the firm is facing situation of capital rationing, it should accept the investment proposals only if they meet the following two conditions. First, the cost of the proposal does not exceed the funds available, and second, the benefits associated with the proposal should be more than the cost. The following techniques shall help the firm to choose the most profitable proposal given the cap on capital. First, discounted cash flow techniques, under which two methods are present. First, NPV, which is net present value method. Second, profitability index method. Next, second is programming techniques. Under programming techniques, we will study about integer programming and linear programming. Let us discuss each of these in detail. Discounted cash flow techniques. Following DCF techniques can be used to make up a decision under capital rationing. First, net present value. Second, profitability index. Let us study net present value NPV in detail. NPV remains the most preferred technique even in the situations of capital rationing. A firm should select all the proposals with positive NPV. Let us consider the following example. There are three projects with initial cash flows as C0 of minus 20 lakh rupees, C1 of 50 lakh rupees and C2 of 10 lakh rupees for project X. Similarly, C0 of minus 10 lakh rupees, C1 of 10 lakh rupees and C2 of 40 lakh rupees for project Y, and C0 of minus 10 lakh rupees, C1 of 10 lakh rupees and C2 of 30 lakh rupees for project Z. The NPV of the three projects at 10% are 34, 32 and 24. According to the NPV rule, all three projects should be accepted as all are resulting in positive NPV. But if the firm has ceiling on capital, let us say rupees 20 lakhs, then the firm can choose any of the following investment decisions. First, invest rupees 20 lakhs in project X and achieve the NPV of rupees 34 lakhs. In both project Y, rupees 10 lakh rupees and project Z, rupees 10 lakh rupees and achieve NPV of rupees 50 lakhs. Next is profitability index PI. Under capital rationing, the firm should not restrict the proposal selection to the positive NPV rule only, because what firm is interested is in the highest NPV per rupee invested rather than the maximum NPV. Therefore, a better approach is to use profitability index in the case of capital rationing. Profitability index PI is equal to present value of cash inflows upon present value of cash outflows, or profitability index PI is equal to net present value NPV upon investment. Let us look at our example once again and try to figure out the profitability index for all the projects. The profitability index of the three projects is 2.7, 4.2 and 3.4. If we rank the three, then project Z is better than project X, project Z is better than project X and project Y better than project Y. If we rank the three, then project Z is better than project X and project Y is better than project Z. By using profitability index as a selection criterion, the firm can make better decisions because now we are not getting the NPV of projects alone but their benefit cost ratio as well. Following the PI ranking, if the firm has limited capital of rupees 20 lakhs, then it should invest in project Y and project Z. Investment in these projects result in highest NPV per rupee invested. Although the above method provide investment decisions, but it has some limitations. Profitability index as a selection criterion fails to give desired results in two situations. First, multi-period budget constraints. Second, project indivisibility. Multi-period budget constraints, where the budget constraint is not restricted to a single period. In the example above, the constraint was limited to a single period only. However, if the budget constraint extends to multiple periods, PI is more likely to not give the desired results. Let us say we have budget constraint in 2 years. Year 0 rupees 20 lakhs and year 1 rupees 35 lakhs. Also, the firm is expecting a new project opportunity in project A in year 1. So here, if after following these rankings, the firm selects project Y and project Z by investing rupees 20 lakhs, the whole budget shall be exhausted. However, these two projects are expected to generate cash flows of 20 lakhs collectively in year 1. Thus, total amount available for investment in year 1 shall be rupees 20 lakhs plus rupees 35 lakhs, that is rupees 55 lakhs in total. And this is insufficient to meet the cost of project A. On the other hand, if firm selects the project X with lower NPV and PI ranking, we will generate rupees 34 lakhs in year 1, which on adding with the budget amount becomes rupees 69 lakhs. This amount is well sufficient to meet the cash requirements of not only project A but also save an amount of rupees 9 lakh also. Project X and A have lower PI ranks than projects Y and Z, but they have higher total NPV of rupees 65 lakhs. Next is project indivisibility. Due to the indivisibility of project, sometimes it is desirable to accept multiple lower ranked smaller projects than a single large project. Let us say a firm is considering following projects A, B, C, D and E with cash outflows of rupees 1.5 lakh, 1 lakh, 0.8 lakh, 0.7 lakh and 0.6 lakhs respectively. Also, the NPVs of these projects is 0.6 lakhs, 0.45 lakhs, 0.5 lakhs, 0.3 lakhs and 0.25 lakhs in the same order. The PI of these projects are 0.4, 0.45, 0.63, 0.43 and 0.42. The ranking of the projects is C, B, D, E, A from best to worst. If the firm has a budget constraint of rupees 2,20,000 and projects are divisible, then the firm should go by PI ranking and select projects C and B entirely and 4/7 of project D are non-divisible, then it should consider various combinations of projects to find out their respective total NPVs. The combination which gives the highest total NPV is selected. So when should we use profitability index? PI should be used as a selection criterion to choose projects under following situations. First, single period budget constraint. Second, divisible projects. The limitation of profitability index can be solved with the programming techniques. These are as follows. First, linear programming. Second, integer programming. Now, we will discuss about linear programming. Linear programming is an optimization technique where one seeks to maximize or minimize an objective function expressed in linear form subject to a family of linear constraints. This approach is suitable when the project is facing capital rationing problem and has multi-period budget constraints. The objective can be either of the two. First, maximize total NPV. Second, maximize present value of cash available for dividends. This approach assumes that the projects are indefinitely divisible. That is, the decision variables can take fraction values also. Let us understand the approach with an example. ABC Limited has a capital budget of Rs 14,000 for year 0 and Rs 5,000 for year 1. It has investment opportunities in the following three projects. ABC with cash outflows of 5,000, 4,000, 8,000 and 4,000 for project A. Similarly, 8,000, 2,000, 6,000, 5,000 for project B and 6,000, 6,000, 4,000 and 12,000 for project C. All these are from year 0, year 1, year 2 and year 3 respectively. The cost of capital is 10%. The projects are indefinitely divisible. Note that this means we can invest in any fraction of a project and that all the cash flows and therefore the NPV will also be this fraction of those above. You are required to formulate the linear programming model to decide how to best invest the capital available. Of year 0 can be put to deposit for 1 year at the solution rate at the interest rate of 7%. Solution. Let XA is equal to proportion of project A invested in, XB is equal to proportion of project B invested in, XC is equal to proportion of project C invested in, ST is equal to amount put on deposit at time 0. The objective is to maximize total NPV. Maximize NPV is equal to 976XA plus 2529XB plus 862XC minus 0.02727 ST. Subject to the constraints 5000 XA plus 8000 XP plus 6000 XC plus ST is less than or equal to 14,000 times 0, 4000 XA minus 2000 XB plus 6000 XC is less than or equal to 5000 plus 1.07 ST time 1, where XA, XB, XC is greater than and equal to 0 and less than 1. ST is greater and equal to 0. Working notes. NPV for surplus in deposits is equal to minus ST plus 1.07 upon 1.1 ST is equal to minus ST plus 0.972727 ST, which is equal to ST minus 1 plus 0.972727, which is equal to minus 0.02727 ST. Next is integer programming. The linear programming assumes that projects are indefinitely divisible. However, in practice, one can't undertake fractions of the project. The firm has to either accept it or reject it. So, a better approach than linear programming is integer programming. It assumes that the projects are non-divisible and decision variables can take only two values, 0, reject and 1, accept. For example, PQR Limited is considering the following investment proposal for the upcoming year. The values have been given in 1000. Projects have been given to you as A, B, C, D. For example, PQR Limited is considering the following investment proposals for the upcoming year. In column wise project from A to E has been given to you. Outlay in year 1 has been given to you in 1000. Year 2 outlay in 1000 have been provided. Next is NPV have been given to you. Additional information. A. Budget constraints for the 2 years are year 1 rupees 2 lakh, year 2 rupees 1 lakh. B. Project B and C are mutually exclusive. C. Out of projects D and E, at least one must be selected. D. If project A and D are accepted together, then the total cost will be reduced by 5% while NPV will increase by 10%. E. Surplus funds, if any, of the first year can earn 15% return and can be used in the second year. F. Cost of capital is 10%. Formulate the above as an integer programming problem for arriving at the optimal mix of the project. You are not required to solve the same. Solution. First, let us assume the decision variables associated with the projects are XA, XP, XC, XD and XAD. The objective function will be maximize NPV is equal to 60 XA plus 56 XP plus 40 XC plus 35 XT plus 38 XC plus 104.5 XAD plus 0.045455S. Subject to the constraints 100 XA plus 60 XP plus 30 XC plus 45 XT plus 40 XE plus 137.75 XAD plus X is less than and equal to 200. It is year 1 constraint. 30 XA plus 50 XP plus 40 XC plus 20 XE plus 28.5 XAD is less than equal to 100 plus 1.15 S, year 2nd constraint. XP plus XC is less than equal to 1, mutually exclusive. XT plus XC is greater equal to 1, at least one project should be selected. XA plus XT plus XAD less than equal to 1. XA, XP, XC, XT, XE, XAD is equal to 0 or 1. Working note. Condition number D says if project A and D are accepted together, then the total cost will be reduced by 5% while NPV will increase by 10%. Therefore, NPV for funds is equal to minus X plus 1.15 upon 1.1 S is equal to minus S plus 1.045455 ST is equal to S in bracket minus 1 plus 1.045455, which is equal to 0.045455S. Let us now summarize what we have learned so far. Capital rationing refers to a situation where the firm is constrained for external or self-imposed reasons to obtain necessary funds to invest in all investment projects with positive NPV. The situation could be solved by adopting DCF techniques or programming approaches, where the projects are divisible and there is a single period budget constraint. One should go for the profitability index ranking as the basis for allotment of funds. Where the projects are divisible and there is a single period budget constraint, one should go for the profitability index ranking as the basis for allotment of funds. Where the projects have multi-period budget constraint, the firm should use mathematical programming approaches to arrive at result. Integer programming is a better approach over linear programming in the case of non-divisible projects. Project A has year 1 outlay as 100, year 2nd outlay 30, NPV is equal to 60. Project D has year 1 outlay 45, year 2nd outlay 0, NPV 35. Now, project AD, year 1 outlay would be 0.95 multiplied 100 plus 45 is equals to 137.75. Year 2nd outlay 0.95 in multiply 30 plus 0 is equal to 28.5. NPV will be equal to 1.10 in multiplication 60 plus 35 is equal to 104.5.